once you catch someone, you have 2 laps to pass them. If you can't get that job done in 2 laps, the amount of downforce you lose off the front just scrubs across the road. You've lost your pace advantage to the car in front.
Today on the HPA Tuned In podcast, we have Sam Potter, who is a race engineer in the Australian V8 Supercar series. So for maybe some of you guys who don't know much about V8 Supercars, it is a touring car class. The cars are relatively trick under the skin, even though they look a little bit like road cars from the outside. Essentially a full space frame, a lot of engine power, all front engine rear wheel drive, not much aerodynamics. All pro drivers, certainly a really high level of motorsport, and definitely the highest level of motorsport we have in this part of the world in Australasia, one of the leading classes for sure.
Also, often referred to as taxi racing.
Yeah, people definitely tend to refer to them as taxis. And, I think for a long time, the taxis that tend to roam the streets here in Australia and New Zealand, Ford Falcons, Holden Commodores. This is largely what was making up the V8 Supercar grid at one point. And I think as you guys will hear today, as we head through the interview, you'll certainly won't be thinking them as being anything like taxis after we go through it today. They're very, very sophisticated underneath the skin, and some very clever people working in that series as well.
No doubt.
So one of the things I wanted to talk about before we got into the actual interview today was talking about string-based wheel alignment. This is something that has comes up quite a few times for us. It's something that we teach in some of our courses as well. And really, I think a lot of people hear the term string-based wheel alignment and they probably think it sounds a bit backyardish. Sounds amateur.
We definitely get a lot of people debating that on our posts.
For sure. And really, for anyone who's not aware, the idea of a string-based wheel alignment system is essentially setting up a reference measurement box around your car where you've got some bars, one at the front, one at the rear. The idea with those bars is it holds these strings parallel to each other. And all those strings really are just giving you a reference point to measure the toe positions or the toe angles of each part of the car. It does sound maybe a little bit strange if you're not familiar with the idea of a string-based wheel alignment, but in my experience anyway, in lots of different racing series, all the way from pretty close to the top to more or less to the bottom, this is a pretty widely used technique, and in my experience anyway, it's certainly very accurate if it's carried out properly.
Yeah, I mean, definitely, we see this literally at the top levels of motorsport. When we visited Jodasport in the UK, run Le Mans prototype cars, they use exactly the same system, literally string, albeit their fixtures are a little bit more advanced to just make their setup quicker. And I mean, you've come from supercars as a race engineer yourself, so you see supercars in the pits between sessions, and they're always on the scales with the strings on them. So yeah, it's not backyardish at all. It is a legitimate technique.
Yeah, and I think, as long as you take care with setting that stuff up, I mean, the string can't not be straight.
Yeah, definitely. I mean, like anything, it's all a case of the devil's in the detail, and a little bit of time spent setting up is going to be critical there. Now, for those who maybe want to learn a little bit more about string alignment or alignment in general, we do have a range of courses, in particular our Motorsport Wheel Alignment Fundamentals course. And if you are interested in that course, we do have a special podcast offer. You can use the code podcast75. That'll get you $75 off the purchase of your first course. And you can find all of those courses at hpacademy.com/courses.
With all that said, let's get straight into the interview with our guest today, Sam Potter. So it would be good to start with, Sam, if you could just tell us a little bit about your background, where you're from, what did you study at university, and what's your role now? What does that involve?
Yeah, so I was, when I grew up, I guess I wasn't hugely into motorsport. I had a slight interest in F1 when it was on. You could always hear them from home, running around the track. But I went to university, studied mechanical engineering, and then I think it was the 4th year or 3rd year at university I came across the Formula SAE program, and I thought that looked like a bit of fun, so got into that. That then led me to looking for a job in motorsport, which got me a job as a student at what was called FPR back then, Ford Performance Racing, which was a partnered company with FPV. And then in 2012, one of the data engineers quit and moved to a different role, a different job. Sorry, he wants to become a firefighter. So I got the call up from the engineering manager if I'd like a full-time job at FPR, which I took up as a data engineer, working with Dave Reynolds and James Small, James Small's obviously NASCAR at the moment. He's a successful crew chief now over there with race wins. And then I've been at FPR, which has gone through Pro Drive Racing and now Tickford Racing, name changes, and ended up in 2017 as a race engineer with Jason Bright, then Richie Sanoe, and then finally Cam Waters in 2019.
How important is that mechanical engineering background to what you're doing now with engineering the cars and data in general?
It is relatively important. I guess it depends on what aspect. So I'm probably more of a data. I do a lot of programming and a lot of data analysis, which I guess I learned a bit of that at uni through my mechanical engineering degree, but I also did a maths degree as part of science.
Right.
And I probably use a lot more of that, to be honest, than I do my mechanical engineering aspects. But if the design guys, they obviously, a couple of the guys, they're race engineers, but they also double up as design engineers. And they probably use their mechanical engineering knowledge more so. But there also, I guess there is a lot of, even with the programming side of things, the mechanical knowledge with like vector maths and all that sort of stuff that we learned in my mechanical engineering degree sort of blend together with the programming and math sides of the science degree.
I think it's probably fair to say there's probably a few different types or categories of race engineer depending on your interest and your background as to whether you're a more sort of practical, experience-based guy and sort of doing things a little bit more maybe off feel as opposed to maybe more an analytical direction. You agree with that? Yeah,
definitely. It's definitely. I've worked with a few different engineers who've definitely come from those sorts of thought processes. Some are much more data-driven and much more analytical, and they'll take the driver's comments on board, but they need to see that in the data as well.
Mm-hmm. So, like a little bit left field, but did you actually ever get involved in motorsport as a driver? And so that leads into, even if you weren't, do you think in general actually having some hands-on experience behind the wheel can be beneficial for a race engineer or a data engineer?
Yeah, well, I definitely didn't have any driving experience prior to this, but a couple of guys I know, not necessarily, I guess James Small's probably a good example. I'm pretty sure he, as an engineer, did a couple of test days where he got in the driver's seat and he tried out a few different things. He came through Formula Ford and all that sort of Formula Ford, and then go-karts Formula Ford, and then ended up doing a couple of test days in a supercar. But yeah, for the most part, most engineers haven't come necessarily from that driving background, but they've just come from that motorsport interest.
Sure. On that, I think, well, I certainly never had the chance to drive a supercar. When they do ride days every now and then, and the ability to get in the passenger seat and really feel like what's going on in the car, I think you get I got a surprising amount of feedback and information actually getting a ride in the car, even though you're usually running around on absolutely terrible tires. You really feel the balance, you feel the grip, you feel the transitions. Like, what do you take away from getting a ride in the car, Potsy?
Yeah, well, I remember my first ride, I was like, this is one rough ride. Like, it's so different to what I actually imagined, I guess. But obviously there's no insulation, so the vibrations, the heat, it's a completely different little world in the car than what I'd imagined it was going to be. And it's definitely, it's with the lateral G they pull and the longitudinal G. I think it's the braking probably more than anything that impressed me the most, the ability to brake, and then that initial turn-in phase where you get the higher longitudinal and the higher lateral G. I found quite impressive.
Yeah, I think it's fair to say that most people who've never actually been in a professionally built race car would probably have their eyes wide open when they realise what a properly built race car is actually capable of doing. And even as Tim says, on some pretty average tyres, and probably with a driver who's only doing 7/10 on a ride day, I'd imagine.
And I think the incredible thing about them is even though, from the outside, this probably, well, for some people that aren't familiar with supercars, we'll get to talking a little bit more about it in a second, I'm sure, but even though the cars are maybe don't seem like a super impressive formula as far as, they're very relatively heavy, relatively small tyres, not much downforce, a lot of power, a lot of engine power, but it is, even as someone who has got a little bit of their own racing experience from the driver's seat, it is absolutely just mind-blowing what it feels like to spend some time in a car like that with a proper professional driver. Like it was truly overwhelming. So I can't even imagine what it feels like for someone that had never even been in a race car at all before. It's actually, and to be able to experience that, it's just eye-opening. Like I can't believe these guys do this, and they do it while like door to door when they're racing with other 25 other cars on track.
Yeah, and the vision out of the cars is obviously fairly limited as well. Like keeping your wits about you while you're on track, knowing who's near you, and their ability to sense the perimeter of their car and how close they can run to another car, and all those sorts of things are pretty impressive.
Yeah, and I think when you're like as an engineer, we spend our time buried in laptop screens, most of the time.
Yeah.
Whether that's on the pit wall or whether that's back in the truck, but I find you become quite disconnected from the reality of what they're actually dealing with. We can sit there and say, you need to do this different, or what's going on here, and but I think it's really important and interesting to experience that sort of real life, what's actually going on in the car. It's so incredibly different. It's incredible.
Yeah, I mean, it's also like what you say. You get buried in the numbers and the graphs and all that while you're following them around track, and then you make a change and you think, and obviously the change you've made, you zoom in on it on your data and you can see what it's doing. But you talk about a couple of mil, the car is now 2 mil higher in the front ride height, or 1 mil higher in the rear ride height, and you're like, yeah, that's what you were chasing or whatever. But but they can also repeat that lap after lap as well.
Mm. Let's just come back a little bit, because we've got a lot of viewers and listeners from all around the world, and supercars in Australia is very much an Australasian thing. So can you sort of give us a bit of a 30,000 foot view on what the Supercars series actually entails?
Yeah, so it obviously was originally based around the Ford Falcon and a Holden Commodore, so four-door sedans. And the original 2000 blueprint formula was mostly built around OEM panels, but there was a space frame sort of chassis that it was built around, and a lot of panels were steel. And they've sort of slowly evolved into what it is now, where it's a chassis that is standard across the board, and the panels that we bolt to it are what pretty much dictate whether it's a Ford or a Holden, or there's also been Nissans and Mercedes and Volvos over the years. But they're all composite panels, and the panels themselves are probably a bit stretched and warped to fit the chassis nicely, so they don't match up to the OEM panel exactly. Probably they match up more than the NASCAR do to their equivalents.
Yeah.
But we run a 5-litre pushrod V8 to a sequential transaxle gearbox with transaxle that has a spool differential in it. Same tyre front and rear, which is unlike some categories that run a steer tyre and a drive tyre. The tyres we run, they do both jobs. So it's quite under-tired as well. They are a proper racing slick, but relative grip and relative tyre width, they're quite on the smaller side, and they're very heavy cars as well.
And as Tim mentioned earlier, a reasonable amount of power, particularly given the fact they may be a little under-tired.
Yeah, 650 horsepower, I think, sort of the number. We're all capped at a certain horsepower range. And it's from 6.5 up. You have to meet a certain integral under the horsepower curve. So everyone's relatively similar. But yeah, a lot of power.
And what's the approach for how teams sort of, do they build these things? What is it different across the pit lane? How does it work, like as far as manufacturing capability, what you have to have or what you can have?
Yeah, so I think most teams back in the day used to build their own, but it's slowly gone away from that, where we've had, where I work, Tickford, we've built We're up to 22 cars that they've built in-house now. And they get sold on to other teams or the Super 2 series, which is like the feeder series to supercars. And then we have AAA. They make their own chassis. And then there's also other chassis manufacturers called Pace Innovations. They also make chassis for, they're not a team themselves, but they do specialize in building supercar chassis, and they've provided them to other teams as well who buy them directly from Pace Innovations.
Sorry to cut you off there. So in a nutshell, you've got the standardized tube frame chassis or space frame chassis that's across the board, regardless of the body shell that's kind of draped on the top of it.
Yeah.
So your suspension pickup points are all standardized as well. So where are your freedoms? Where are the differences between the different teams? What sort of levers have you got available to pull to make your car better than the next?
Well, so the rear is controlled. The pickup points are controlled. The uprights controlled. All that sort of stuff's controlled. The only freedoms in the rear are the rear roll bar system. You're allowed to do your own system. There's just a couple of rules on what part of the lower control arm that your ARB pusher picks up on and where the rocker needs to be, and also where the ARB tube is a bit of a region where it needs to be on the chassis. But otherwise, how the rocker ratios work and the overall dynamics are free. And the front, the pickup points are free for us to design within Windows.
Okay.
So
you can get a bit of variation there on what
front.
You sort of think is the direction to go forward with.
Yeah, it's pretty minimal, so you effectively do have the same front pickup points, but the windows are quite small. But there is a little bit of variation there, and obviously the front geometry in terms of caster, cambers, toes, all sort of things, they're free as well in the front.
Yep.
There's rules you got to fit, but yeah.
What about downforce levels? Like, what sort of region of downforce are you guys working with at the moment?
I think the number is at 200 k's an hour. It's like 300 kilograms total, which is about 100 on the front, 200 on the rear, and that's purely straight line, 200 k's an hour coasting. That's the downforce. Obviously, that changes a lot once you start to pitch the car and roll the car, which we don't necessarily have access to test data for that, but there's simulation data or CFD data that we can try and leverage for that, but doesn't always marry up exactly.
For sure. And that's that you'd definitely say that's in the lower sort of downforce region as far as like modern motorsport.
Yeah. I mean, they're taking away, for Gen 3, they're taking away more downforce again. But it is pretty much as low as you can get for a tin top supercar, I think, or tin top professional level race car.
One of the things, I've watched the series and pretty avid follower myself. I know that one of the things that's sort of been mentioned repeatedly is the aero wash and the problem that drivers have being able to follow a car close because they lose that downforce off the front splitter, and then the car tends to want to push wide or understeer. Has there been any changes for the 2021 season to try and address that, or is that coming in Gen 3?
That's coming in Gen 3, but yeah, you're right. Pretty much you have a window of 2 laps. Once you catch someone, you have 2 laps to pass them. If you can't get that job done in 2 laps, the amount of downforce you lose off the front just scrubs across the road. Now you generate tyre temp, and then the front tyres go over peak, and you've lost your pace advantage to the car in front. So it's really quite a minimal window to get that job done.
We see that quite often. So that's where the driver's basically using up the tyre because they don't have that aero downforce at the front.
Yeah.
So, but then the tyre overheats or degrades and you're gone.
Yeah, and it just takes. You could get it back. You often see sometimes the driver will pull back and try and give himself a second or two in front to the car in front if they can afford that time loss, to try and get the tyre temp back down, try and get the tyres back in a better window, and then they might have another crack, but it's pretty hard to do.
Sure.
What about from a data perspective, Sam? Obviously data, log data and data analysis is a pretty big part of all modern motorsport. What sort of sensors have you got available, and how are you making use of those throughout a race weekend?
So we have obviously got steered angle, throttle position, brake pressure, engine RPM. There's sort of, I guess, a lot of the sensors that we can compare driving styles, driver to driver. We have G-force sensors, which are logged at quite a low rate these days. They were back in the day logged at maximal rate, which I think was 100 hertz. I think we're down to 10 hertz. I think the rule is, which is next to useless.
And that's a category requirement now.
Yes,
just to be clear as well.
Yeah, category requirement. It's to try and level the playing field a bit to those smaller teams that haven't got access to simulation software and haven't got the ability to analyze data like some of the bigger teams do. It's to try and level that playing field a bit. But it does make it hard though to help a young driver coming into the category to try and get them up to speed and try and teach them what these experienced drivers are doing in the car and how they're generating lap speed. Can make it a bit hard for that. We've got other sensors like obviously engines have plenty of sensors. They've got coolant temperature, oil pressure, oil temperature, coolant temperature. We have cabin temperature to keep track of cabin temperatures for the drivers, make sure they're not overheating. We have cool suit temperature. They run a cool suit vest in supercars, which they pump water through a box that's full of dry ice, and then that gets pumped through a vest that they wear that's got little capillary veins all through it. Keeps the drivers relatively cool. I think the water's usually around 3-4 degrees. It runs around them. So,
and just again for reference, for those who aren't aware, you're running around a whole bunch of racetracks in Australia, generally over summer months as well. So what sort of cabin temperatures could you be expecting as a driver at some of the hotter races?
60 degrees plus. I mean, we have 3D printed parts in the cars. And back in the early days when 3D printed parts were relatively new on the scene, we'd often have those early parts would just come back and they'd be melted just because they're obviously past their own printing temperature.
Yeah, and that's, there's a safety aspect there as well, right? As far as keeping the driver cool, I think it's probably part of the rules, right? As far as making sure you're not getting people losing too much fluid.
Any day that's over 32 degrees in the local town, was forecasted to be over 32 degrees in the local town, it is a requirement that the drivers have a working cool suit. And if it fails during the race, if it freezes, the pump fails, or whatever failure it is, the car will get black flagged, because supercars have access to all our telemetry on the fly as well. So they can see when the temperature sensor for the driver starts to rise, and they can see there's no current draw on the cool suit pump. They can see it's failed, and they'll black flag the car.
And you guys, I presume, are probably still putting quite a lot of effort into keeping those cabin temperatures down with things like heat shields and different approaches to routing things. Could you talk us through roughly what you guys are doing there? Yeah, so there's a lot of heat shielding, just trying to find new products. This product's called, I think it's called croc skin or something like that. It's like a metal leaf that sticks to a shield that we'll put on the cars on the underside of the chassis, especially around the exhaust area. That's probably one of the hardest things for a taller driver, is that they have to have the pedal box so far forward, so close to the firewall. They tend to feel the heat a bit more than a shorter driver who can have the pedal box closer to them, because the temperatures at the firewall can be like 100 degrees, 80 to 100 degrees at the firewall. And that's even with a bit of shielding as well. That's just from the engine temp, the exhaust headers.
We've actually seen drivers in some of the endurance races as well with blistering on their feet from the heat being transferred into the pedal box, right? Yeah. It's typically the taller drivers that happens to, and it's just the temperature that the brake pedal eventually gets to over those longer races, especially places like Gold Coast when track temps, the ambient temps about 30 degrees. That's where you get that sort of problem happening. Getting back to the data, so there was a bit of a shift in the 2020 season to limit a lot of the data. So you've talked about the logging rates there, but I believe your actual sensor set was also reduced, and something around how and when you could download data from the car plus telemetry. Could you give us sort of a quick rundown on how that all changed?
Yeah, so with COVID, they tried to restrict the number of staff that were required at a race event. And so to do that, they just reduced the amount of data that was able to be analysed and when the data could be analysed. So first thing they did was that you weren't allowed to download a car. Well, actually, so you were allowed to download the car during the weekend, but they'd have with Motec, they'd organised to have a key on all the data, so you couldn't actually unlock the data until post-event when Supercars would send all the teams their respective keys to unlock the data. And then,
so you were kind of blind during the race weekend?
Yeah, you still had telemetry data, but the telemetry data is a bit... it's definitely not as good as the log data. It's got some... it's definitely got relevance, but it's not as good, not as powerful as the log data. Plus the other...
Could you just briefly dig into that and why the telemetry data is different and why it's maybe not your preferred option over using log data?
Yeah, so the log rates are lower. That was a requirement by Supercars. And the channels that we're allowed to send cross telemetry were reduced. But also you're relying on consistent data stream, data feed, which you don't always get a full lap of data with telemetry. You get dropouts, and it's a lot better these days than what it used to be using a 3G network or 4G network. But that's a 4G network now that we use. There still is blind spots, and you don't get the whole track.
Racetracks are never, in my experience, renowned for their great cellular coverage. Always a problem.
No, especially on race day. Yeah. It's usually okay in the lead up to the race, but then as soon as you get to the race itself, everything goes down.
All the spectators turn up, yeah. Instagram, game over.
And it would be really interesting just to hear a little bit about your process, about how you make use of that telemetry, and maybe how that might differ between during a timed session, like practice sessions throughout the race weekend, and then moving to the race as well. Like, what are you looking for in the data? What sort of channels are you making use of? And what does that communication, that real-time communication look like between you and the driver based on what you're seeing in the telemetry?
So obviously we'll overlay with the lap, and that'll tell us where we're making time or losing time relative to that lap that we have overlay. And then we can I usually look at things like throttle position, steering trace. Often you can tell from the steering trace what the car is doing, if it's loose in, if it's understeer with snapping off, or whatever the drama the driver's chasing, and what corners that might be. And then you also look at the throttle trace as well. You can see how quickly they're ramping the throttle, their brake trace. Are they carrying too much brake into the apex? You might be able to overlay with another driver who's better at a corner and see that their brake trace is slightly different. They might be braking a little bit earlier, washing off the speed a bit earlier, and carrying more speed across the apex and actually getting an overall better corner exit, which is overall gain. Not really too much in the way of chassis-specific sensor items that I really look at during a session. They usually require a bit more in-depth look. And usually I try to look at them in a full lap picture, not an individual time instance where you might look at, this G-force at this point, this time, or something like that. I'd look at more trends, like using things like histograms or plotting average understeer or something versus throttle position, and try and get trends that way for a full lap rather than individual time instances.
So this might be, like, obviously you guys have a live timing feed, you've got timing information coming through, and supercars like mini series can break that track down into mini sectors, maybe as many as 10, 12 sectors, whatever it might be. So you may well be looking at those sectors, looking at what your competitors are doing, and then trying to find some trends based off your teammates. Obviously you guys have access to your teammates' data, so between using the timing data and the teammates' data, you can start to build a bit of a picture and really make use of all of those sources.
Yeah, usually I use the timing first to put me in a direction of where we're weak, where we're strong, and then use the data to actually understand what we're struggling with in that sector, what corner it is, because obviously some sectors might have 2 or 3 corners in them, which makes it a bit hard to actually fully pinpoint what the issue is. But if you can see that your teammate is P2 in a sector and you're P20, you can then at least look at that sector on the telemetry, and work out where the time loss is, and then what corner it was, and then work out if it's the entry, the exit, is it driving style, is it the car, could be just the tires, could just
How much reliance have you got on math channels for your analysis as opposed to the raw data?
For telemetry data, usually it's mostly the raw data that we're looking at. But post-session, when we actually have the log data and we have a bit more time to go through it, there's a lot more maths channels. Definitely, we haven't got an understeer channel, so we have our own calculated maths understeer channel, which it's just a number, really. But I guess it's our number that we can compare to ourselves, or we can compare to our teammates to understand the understeer.
Could you give us a bit of insight into sort of how you define a level of understeer in math? Maybe if we can do that without getting super technical.
I guess you're looking at your group limited desire yaw rate. So the car's group limited yaw rate. So the ability of the car to yaw, what it should be able to potentially do, what the driver is asking from the steering wheel, what the yaw rate they're asking for the car is, and then it's kind of the difference between that. Effectively, as to whether or not the car's got understeer or oversteer in that part of the corner.
And how would you define the potential, like what the potential yaw rate would be?
Well, we've kept with the original way, which was before we had any tyre data or any tyre pressure sensor info, which was effectively you just put a constant in there. And I think the constant we used was it's from Bosch actually, and it was a generic race car grip constant, I guess you call it. But I have in the past tried to use tyre data. We can build tyre models from the tyre data to try and calculate the actual tyres or the car's grip ability. But usually just putting it as a constant, and then everyone has the same reference as well when you're comparing to another car. It's just a constant. It's not exact, but it just gives you a reference.
So I think it'd be worth coming back and just digging into a couple of those things. The first thing, math channel, maybe for people that aren't using log data on the daily, might not be too familiar with what we mean by math channels. Can you just explain exactly what you mean by that?
Yeah, so we use i2, Motec i2 for our data analysis. There's other programs out there like PI. There's a few other software programs. I assume they all have a similar function, but with our maths channels, we can look at a raw channel and then we can integrate it, or we can find a max channel, max value that it has across a lap or across a whole race, average values, or you could subtract one raw channel from another raw channel, those sorts of things, I guess. Yeah, just applying functions and manipulating your data to smooth it, or trying to think of what else you can do to it. Yeah.
So I mean, these can definitely get pretty complicated in some cases. Like you say, a really simple example might be maybe taking an average between two channels and looking at, let's say, averaging two front wheel speeds over a lap, and maybe using it to get rid of some of the troughs and peaks. But you could potentially have really complicated functions that it can actually slow the computer down quite a lot.
Yeah. Yeah, I mean, we've, like for instance, that understeer channel has, our maths understeer channel has, I think it's 10 or so sub-maths channels that have their own sub-maths channels that are generally just driven by G-force, steering wheel, and yaw rates. But yeah, I guess to get to that final channel, you'll have multiple sub calculations going on before you get to that final value that you're looking for.
And the other thing I wanted to maybe just touch on that you mentioned before was the idea of a tyre model, and tyre data in general. So what does that look like? How is that data gathered, and what does it mean to make a tyre model from it?
Yeah, so Supercars back in 2018, I think it was, they provided all the teams with tyre data. They got through Calspan in the US. So they send off a bunch of tyres to Calspan and they put it on a belt-driven road with a mechanical arm that can change the angle of the tyre to that road surface and the force that tyre is under vertically. And then they can measure your lateral force generated, moments generated about that tyre. And they do this at different wheel speeds, different cambers, different toes, or different slip angles. And then they provide that data back to us, and then we use a model called the magic formula that is a semi-empirical formula that we feed the data into, and then usually you need a solver that will best fit the data that you get provided to this formula, this magic formula, and then you can use that to then predict if I have this camber and this slip angle at this wheel load, my tyre is going to generate a lateral force of this amount or an overturning moment of this amount. And then we can use that to then try and work out which end of the car has more or less grip that might be contributing to understeering. Maybe it's just a case of taking vertical load off one tyre and trying to distribute that vertical load to another tyre to try and get it to turn, or it could be that the cambers are out of their windows.
This sort of leads into I guess, some of the simulation stuff around optimizing the car setup, where you've got that tyre model like that. I can only assume that makes your life a lot easier. But in a category where they're trying to limit costs, and they've obviously clamped down severely on testing outside of race weekends. So how critical is simulation to being competitive?
I mean, I don't really know what other teams do, but I can only imagine that the other top teams have a very they have a very strong simulation program that strongly correlates to their cars. We at Tickford, we use Atoms, which is it's a software that anyone can buy. It's relatively expensive though, and we use Atoms, which is obviously it's very dependent on your tyre model. It's often driven by your tyre model as to how accurate your data can be. And if your tyre model is skewed in one way, in terms of how your tyre model thinks to generate the best lateral grip, and your car model that you end up getting out in the simulation world will probably reflect that as well, which makes it very important that you can correlate your, firstly ensure that your tyre formula is as correct as it can be, and then trying to then correlate what the car is actually doing on a racetrack on a specific surface as it does in the simulation world, and comparing that back to each other.
When you talk about we talked a little bit about the tyre model and what that is. What do you mean by the vehicle model in terms of simulation? Like what sort of things go into a vehicle model, and how do they interrelate to each other?
Well, the vehicle model is really just a bunch of files that dictate to Atoms the vehicle mass, where the COG is of, I guess you can do the COG of the car, or you can do the COG individually of all the different components, like the COG of the engine, then you have the COG of the car, and you put it all together. Where all the suspension arm points go, where all the linkages go for your ARB rockers, the spring rates, damper forces, and how the damper forces relate to its velocities. I guess how the steering wheel relates to what the tires are doing. It just builds that model together so that when you feed the simulation inputs, such as steerings or throttles or whatever, it'll react all the points in the car and all the points in the chassis. It'll move them around correctly and distribute the forces as it needs to.
So it's really like a mathematical representation of physically what you've got on the car.
Yeah, exactly. Yeah.
And how well does that sort of validate out when you take the car to a track with a setup you've developed in the simulation world? Do you normally find that that's going to put you in the ballpark straight out of the transporter, or is there normally a bit of work to do in the real world?
Well, the biggest and hardest thing with simulation is, what are you actually trying to achieve? What are you looking for? Because, I mean, you can do as many runs as you want and produce all this data, but you really, at the end of the day, and you can have atoms predict a simulation lap time, but that simulation lap time never really means anything. And at the end of the day, it's all about trying to understand what aspect of the car you might be trying to influence. Run your simulation, and then understand how the simulation thinks it's influencing that part of the car, and then correlating, and then putting the part of the car and doing a lap, and then correlating that data to what you actually thought you were meant to achieve and what actually has happened on track. But then actually understand, is that actually making the car faster or slower? That's the hardest bit.
Yeah, fair. It's also beyond the actual computer simulation, do you do any driver simulator work as well to work on validating a specific setup? No,
not yet. We're probably still a little away from that in supercars. The ability somewhat exists with I can't remember these programs. There's some racing programs out there now that are relatively realistic, and you can change similar aspects to the car that we can change, like ARB rates, spring rates, ride heights, all these sorts of things that affect how the car then behaves in the simulation world when you drive it. But one of these programs, the supercar setup that we actually run, if you bolt that into that program, it would be nowhere near a fast car in the game. So
not particularly useful.
Not yet. There is talk about programs that are out there that are getting closer to that point, but not quite there yet. Not like F1.
No, fair enough.
One of the things I thought would be really interesting to talk to you about, as far as maybe digging a little bit more into the setup aspect, would be just sort of your approach to damping, using damping in general. I know it's something that we get a lot of questions about here at HPA when we're talking about car setup. Damping's one of those aspects that probably tends to, overwhelm or confuse or intimidate people quite a lot. And I think it'd be really useful just to go through from a little bit of a first principles discussion with you, someone that's doing this stuff and using it every day, sort of get your perspective on an approach to understanding damping and maybe how you might use it to actually make your car faster. So, to start with, in your eyes, what's the purpose? What are you using dampers for? Why do we use them on the car at all?
I guess we're trying to control the tyres contact patch. So the contact patch is the tyre sitting on the road. We're trying to reduce that amount of variation that the tyre is seeing in terms of vertical force. And that means that the contact patch itself will be varying less as well. It should be a more constant area in contact with the surface of the road. But then also tyres are they're load sensitive. So if we can reduce the amount of change in vertical force that this tyre sees, that all four tyres on the car see, we will overall improve the grip of the car. But obviously you could get to a point where you over damp the car so much that the tyre stiffness and the tyre internal damping aren't very well matched, and you get the tyre doing it on its own surface, or you could get oscillations in your suspension where, if you're under damp, say, where the tyre itself, the suspension itself is allowing the tyre to unload and load constantly on the circuit. So you got to try and find that middle point.
When you're talking about minimizing that vertical load variation, where are these variations in vertical load actually coming from in the first place?
Obviously, there's the springs themselves. From a hysteresis point of view, the springs will. Obviously, if you have a spring and you spring it out and then you let it go, it'll continue to vibrate at a frequency which if you had that spring in the car, even though they're very stiff springs, this spring itself will be oscillating that small amount, which will translate all the way down to the tyre. So the tyre is going to be seeing a varied oscillation. That's where you want the damper to control that spring force frequency. And then obviously you've got the road input frequency as well. You've got bumps all over the track. And obviously with supercars, we've got big curbs that the drivers like to hit and two-wheel over. So when that obviously really upsets well, we can't really do too much when the tyre's in the air, but when it lands, try to use the damper to control the amount of time it takes for that car to recover and stop the loading and unloading of the tyre on recovery.
Do your dampers have blow-off valves for allowing the drivers to run those curbs so aggressively without upsetting the car more than is going to be unavoidable?
We used to, not anymore. We have a controlled damper now in the category, so it's the same damper front and rear. All teams have the same damper. So there was a fair bit of development in that area, and that was one of the ways that supercars decided to clamp down on the amount of development was on dampers, because they are considered a bit of a black art, I guess.
What were you using before, as far as what sort of degrees of freedom did you have? What adjustments did you have, and what do you have now?
So the degrees of freedom there were 3 damper manufacturers that you're allowed: Supershock, which is an Australian company, Olin's, which is a major international company, and Sachs, which is also a major international company. They were the 3 dampers that we were allowed, and within each of them, there were certain parts that we were allowed to run. They were on a list of allowed parts from suppliers that we were allowed to build our dampers with. But any obviously we were restricted to certain pistons, but then what shim stacks you ran and what shim preload you ran on each of them was completely free. And valve housings, valve bodies, all that sort of stuff was completely free. Well, not completely free, but free within. There was 3 or 4 different options, say, for a specific damper type, and you could run different springs and preloads on them, or different, just internal springs, I say, not external springs, but internal springs to make the damper work and operate.
So literally now you're clamped down to every single car is running the exact same shock, same internals, etc. Yeah,
they are adjustable. They're still compression and rebound adjustable, but the actual profile of the curve is pretty much set for everyone. It's just, I guess, a question of biasing the damper to rebound or compression and what levels of damping you think you might require.
When you're talking about those adjustments, when you talk about rebound and compression, could you give us a little bit of maybe a high level view of what sort of car characteristics you might want to be affecting by making changes to, if you want to break it down to low and high speed regions as well, that's fine, but it'd just be good to give people a bit of a perspective on that.
Yeah, well, pretty much it's the low speed region, so typically up to sort of, I guess, 100 millimeters per second, maybe up to 200 millimeters per second is sort of the region that I generally look at. I don't really look at anything past that. I'll
stop you there just to clarify. When we're talking low speed and high speed, you've talked about 100 to 200 millimeters per second. So there's nothing to do with car speed. You're talking about the speed of the damper movement, correct?
Yeah. Yes, correct. Yeah, the speed of the damper movement. So it's sort of, I guess it's probably more between the 50 to 200 mils per second is where I usually look. But the 0 to 200 is, I guess, slow speed is probably more considered to be up to 100. But the 50 to 200 is where I'm looking at, and it's, I guess that's sort of the things like body roll and pitching under brakes and that part of the car's movement that we're trying to control the rate of, to then try and control the weight, the tyre load variation that the tyres are seeing at a specific end of the car or a specific corner of the car, whether it's longitudinally affected or laterally affected or both.
So it's much more in the region of the driver's inputs when they hit the brake pedal, when they're in the steering wheel, when they're getting on the throttle. This is sort of changing the rate or the speed at which the suspension compresses or extends or the chassis rolls. This is really having the most influence.
Yeah, I mean, you're not or you shouldn't be using it to change the final value that the car sees, but you just change the rate at which the car gets to that point.
Yeah, and I think that's probably a really important point to bring home. There is a lot of people, understandably, when they're not doing it for a job, I don't blame people for being confused on it, but when we're talking about making damper adjustments, we're definitely not talking about, you're not really talking about making the suspension any stiffer or changing the rate of it. It's really just about the amount of time it takes for the car to settle in its final position, to whatever input you've got. So when people are doing a damping click on a lot of aftermarket coilover dampers, for example, have usually got a single adjustment, which is usually largely low speed rebound. When people are turning those knobs and feeling how it's affecting their car, it's important to understand it's quite a different thing from making a stiffness change with a spring.
So it's a transient thing, not a steady state thing.
For sure. Yeah.
Yeah. So that's actually the way we look at car setup is generally purely based on a steady state, and we have balance numbers and roll gradients, and that's all pretty much calculated without any consideration to dampers. And then obviously we go and add dampers in there, and probably confuses us a bit more with our roll moments and our balance numbers that we think that we have. But yeah, it just, the dampers themselves is just changing the rate. And obviously rebound's a very powerful tool, and that's potentially why that's the tool available to a single adjust damper, and it's a lot more powerful than the compression side, and usually it slows the rate of roll by slowing the rate of extension on the unloaded front or the unloaded rear. So if you're turning left, for instance, the rate at which that front left damper extends to stay in contact with the road will be a lot slower if you put more rebound into the car, which will then slow the rate of roll.
When you're on track during a race weekend, what are the most common changes you'll be making to dampers? You said you've got two adjustments there per damper, so what would you tend to be spending most of your time actually adjusting?
The rebound side, I guess for reasons I just mentioned, but also for the fact that the dampers that we do have are very rebound sensitive and not so compression sensitive. We can adjust the compression side, but definitely driver feedback is a lot less sensitive to the compression, and the dampers themselves the damper curves themselves don't move a lot with the compression adjustments.
Earlier you said that the cars are equipped with shock travel potentiometers, damper travel potentiometers, but you're also limited on logging rate, which I assume affects the usefulness of those. So are you basing damping changes on the data, or is it really predominantly driver feedback?
It used to be back in the day we had 500 hertz logging rate, which was very good for analysing damper, having a damper analysis. But yeah, nowadays I think it's 10 or 20 hertz. It's very small, and it does make it really changes the way the histograms look, which then changes your ability. It changes the way you look at the data to analyze it compared to what we used to have, and it probably makes it a bit more questionable as to what we're trying to achieve with our dampers.
I guess if you're looking at a sample every 10th of a second, you could miss a whole event in damper movement between two samples.
Yeah, exactly. So because of that though, now the dampers are probably a lot more driven by the driver.
Okay. When it comes to data logging in general, dampers usually, when you've got the freedom to do so, they're usually the one that you log the fastest of all of them. Could you just discuss a little bit why that is, why it's so important to log at high frequency if you've got the option to?
The way we look at dampers is it's all about controlling frequencies and oscillations, and the frequency range that we're working in is you can only analyze a certain frequency of a damper up to its logging rate. So the higher the frequency that you log a damper at, the higher the frequency you can analyze it up to. I think it's is it half? I think half of the highest logging rate.
Yeah, so really by them cranking down that, making you log it at a much lower frequency, they're really making you a lot blinder to some of the important aspects of being able to analyze damping. That's what they're trying to do.
Yeah.
I wouldn't mind moving on from damping a little bit and just talking about another of the oddities of the Supercars series is the fact that you're forced to run a spool. And for those who maybe aren't aware of what that term means, you've got no differential action in the rear. It's basically like a solid axle from one side to the other, which has a massive impact on the ability of the car to turn a corner. And from what I understand, probably mainly talking to Tim here, who's been involved with this, there's a lot of, maybe we could say, unusual tuning adjustments that you use in order to actually get a supercar to overcome that spool and actually rotate into a corner. Can you sort of talk us through, maybe in a bit more detail what I explained there, why the spool is problematic and maybe some of the things you're doing to get around that?
Yeah, the biggest problem with the spool is, well, it makes the car understeer. It makes the inside rear wheel, as you turn in, it wants to spin, it wants to turn at the same rate as your loaded rear tyre, which is obviously not good when you're trying to rotate a corner and the inside tyre needs to rotate less. So this is going to make the car understeer. It's actually not a bad thing for drive, on the drive side of when you're on the other side of the corner, but trying to get to that part of the corner makes it a bit more difficult. There's a few different things you can do. You typically wouldn't run a lot of rear roll bar, anti-roll bar rate in a race car, but for a spool differential, you really rely on that roll bar rate to help unload the inside rear tyre, to help reduce its contact patch, to reduce, well, you could reduce it to effectively zero, really, to try and not have any impact from that inside tyre in terms of it driving you straight ahead and making you understeer. Obviously, there's other ways too, which different teams have experimented with over the years with drooping out the rear. But again, that's just to, as you turn in, instead of having an anti-roll bar system or having all your suspension unload that inside rear, you just physically have, as the car rolls, it'll get to a point where the inside rear will leave the ground because it hasn't got any damper travel to go, which in theory, I mean, you're reducing your number of tyres in contact with the road, which in theory is reducing your overall grip, but to make the car turn, that's what we sort of need to do. But obviously on the other side of the corner, having these huge roll bar rates in the rear don't really help our cause there. Trying to we have independent rear suspension that we then go and link with the big
turning
tube,
turning it into a live rear end pretty much.
Yeah, exactly. So it doesn't really, and that's just trading off between those two, trying to get the entry and then the exit right, and then having our rocker system that can have digression that might assist you in that direction, or there's other tools as well that you could use as well for that.
I think that's something that would be good to get a bit of an explanation from you on, is that how you guys approach your anti-roll bar system in general. In my experience, based off the different categories of cars I've been involved with in the past, supercars is quite unique in how it's how they approach using the anti-roll bar. There's a little bit of crossover with what you're talking there with the anti-roll bar. With the spool. Could you talk about how your anti-roll bar works and maybe how you use it differently at different phases of the corner on entry, mid, and exit? So
we use a rocker to change the ratio of movement between the pickup point on the suspension arm, which is, I guess, is directly related to the wheel travel, and then the rate, the motion then at the blade, which rotates the rocker. So if we can have small amounts of blade movement for large wheel displacements, we won't have that much force in the system. So we won't have that much rear roll bar or roll bar front or rear roll bar influence. But then if we change it so the other way, where small wheel movements relate to a very big change in ARB blade movement, we'll obviously then get a lot more force generated from our roll bar system, which will then, as it implies, it'll reduce the amount of roll that the car sees, because obviously there'll be a force counteracting the tyre on the inside wanting to move into droop.
Are you also taking advantage of that sort of realistically you could probably achieve much the same effect just overall with a larger or smaller anti-roll bar, I assume, but are you also taking advantage of that rocker system so that the anti-roll bar reaction force is changing as the suspension moves through compression and droop?
Yeah. So you could obviously do a small tube or a bigger tube to change that force, but we want the big force at certain parts of the corner, typically entry.
Mm-hmm.
We want, effectively, we don't want a roll bar at all in the car if we could on the drive side of things. I mean, on drive, all you're doing is really just hurting the car's ability. If you had having a roll bar system in the car, so you want to try and minimize the amount of influence it has on the drive side and maximize its effect on the entry.
So you're really breaking down the corner into 3 distinct sections there. And I assume you guys are probably looking at some metrics to understand, the sort of the balance metrics at different points of the corner there.
Yeah. I think we typically sort of look at almost 7 phases of a corner, with one being between dropping the throttle to picking up brake in that little period of time. Then you have your bulk brake, which is what we get section 2. Section 3 is your trail brake period, where you start to turn the car in and trailing off the brake as much as you can. That's obviously where the IFL generally creeps in at that point there.
I'll jump in on you there. IFL being
inside front locking.
Of course.
In section 2 prior to that is your rear lock. Generally, your rear lock sensitivity phase. And so section 3 would be your IFL, your inside front locking phase, and obviously you're using what the car's doing in that phase, which is beginning to roll. So we try to use that fact to what the car is doing in that phase to influence the weight on the inside front to reduce the ability to lock that front. And then middle part of the corner where we have the coast, which if that inside rear is on the ground at that part of the corner, that's generally the understeer phase. And then you have your initial throttle pickup to 15%, then your 15 to 90%, and then your 90% plus throttle ramp, which is the section 7, which is really the final bit of the corner.
So even within we just talked through one corner on a racetrack there is a huge amount of information to look at if you're breaking every corner down to this sort of level of discretization here.
Yeah, we try to then, I guess, look at all those different sections of the corner and try and average that out. Not always, but we sometimes try to average aspects of the car that we, or KPIs, like key performance indexes of the cars. We try to then average them down into those parts of the corners as well. So we can say, well, on average, in this part of a corner, we're struggling with X, or we're really doing well with Y.
One other thing I think it'd be interesting to discuss would be the role of driver feedback. How you guys make use of that throughout a race weekend is. It's obviously a pretty big part of what you guys do. The driver is the one in there experiencing it for themselves. But how does that work? Is this you taking notes? Are they giving you feedback during the session by writing stuff down? Is it all on the radio? I mean, you guys move pretty quickly during a session. There's not a lot of time. There's never enough time really during a practice session. So how does that driver feedback loop work for you guys on a race weekend?
Yeah, we record all that driver feedback, and in a session, usually I'll be looking at the telemetry data, and before the drivers come in, I'll have an idea what the car's doing. As soon as the driver comes in, we have a quick 2-3 minute debrief, and I'll already have some ideas in my head as to which direction we should be going, what we need to be chasing, and I'll pretty much I'll say the driver turn to front lock, what's going on there, and he'll just talk to me about what he's experiencing at that corner, what he's feeling, and different drivers will do this differently. Some drivers will just tell you what the problem is, and then they leave you to go make changes, and they don't really have any input. Whereas other drivers I've worked with are much more vocal about what they feel, and we have, I guess, almost like a little mini discussion or debate about what I'm seeing in the data in that one lap period, in that 2 minutes, what he's feeling in the car, and we try to, I guess, come to a middle ground or a conclusion that we then go and put that change in the car and do another lap and try and analyse and try and validate that change.
Given the relatively compressed schedule over a race weekend, and again that lack of testing outside of race weekends, are you limiting the change to just one at a time so you can really validate just that sole change, or are you sometimes forced to make multiple changes simultaneously?
Yeah, sometimes you are forced to make multiple changes simultaneously, but we try to keep the changes minimal so that we don't get too confused and too lost with what change did what, because it can always be more, you collect more data, but then it can be more detrimental to your understanding of, you could put two things in the car, one's doing a good thing, one's doing a bad thing, but the overall result is negative.
Yeah.
And even though you've gone and done a good change,
gets masked.
Probably comes back out. Yeah, it comes out, and you've missed an opportunity. But then also at the same time, if you put something in the car and it goes, it's slower, it's not what you need, it could give you direction to go the other way with that, or with the other end of the car. So even when something doesn't work, it still gives you direction. So it's probably really important to just understand the changes that you're making, understanding what is influencing the car.
Is there any other topics that you think we should know on the supercars front before we finish up?
I guess, Gen 3 will be an interesting for the category. It's to be implemented middle of next year. So that's going to be an interesting change with the lack of knowledge everyone's going to have on that car. It's going to be very different.
Do you see that sort of being a bit of a leveler of the playing field, maybe with some of the smaller teams that are sort of struggling a little bit with Gen 2?
I mean, potentially. Potentially it could go the other way as well. Could give those other teams that have access to simulation, and if they've been able to closely match their on-track data to their simulation data, they should be able to, they'll be starting off in a pretty good spot, I imagine, with their simulation with this new car. So it could go both ways, really.
One of the questions we like to ask on the podcast is, sort of to give a perspective for someone who might be interested in following a similar career path to you. So if, knowing what you know now and all the experiences you've gone through, if you were to give advice to somebody else, or maybe a younger version of yourself, what do you think you'd tell them if they wanted to get to a similar sort of career path as you?
Well, I think a mechanical engineering degree is very important, or a motorsport degree. There's some motorsport specific mechanical engineering degrees, I think, at certain universities. I think a couple of universities in WA do that. I know where I did my degree at Melbourne Uni, there wasn't that option. But there was the ability when I was at uni to do the Formula SAE program, which that's probably a relatively important program, I guess, in getting into motorsport from engineering. So I mean, there's obviously you get involved in all aspects of the car. You even get to drive the car. So I think it's probably relatively important to get involved with that.
It's probably fair to say at this point that Formula SAE has done a lot of good for just about every motorsport category around the world with breeding engineers and designers. I'm pretty disappointed that my university never offered that, unfortunately.
Yeah.
What's coming down the pipeline for you, Sam? You see yourself hanging around as a race engineer for a fair bit of time yet? You've got more aspirations for the future. What do you think?
Yeah, I'm definitely involved in the motorsport industry now. It's going to be hard to move on and get out. I do like the way, I guess, work is structured with motorsport. go to the racetrack, and the racetrack's obviously quite very busy weekends and very tiring. Then you come back and you can go through your data, and then you get some downtime periods where you can actually, for me, my interest is in programming, and I've been able to write program scripts and programming and programs that help the team analyze data and analyze and write reports and things like this for analyzing the data. But yeah, for me, that was obviously probably wouldn't get that freedom in other jobs. Whereas in motorsport, you kind of get that downtime in the off season where you can kind of create a list during the year of things and projects that you want to get on top of, and then you get this downtime to get into them and learn more myself. It's all about learning, constantly learning.
Thanks very much for your time today, Sam. I think that was a really interesting discussion. I'm sure a lot of people will take a lot away from that. So really appreciate you coming on.
No worries, Tim. No worries, Andre. Thanks for having me.
Thanks a lot.
Thanks, mate.
Thanks.
Very good.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.